are doing triangle similarity, and we're going to use 3 theorems to prove that triangles are similar. So we'll talk about our first theorem. Our first theorem is angle-angle similarity, and what it says is if you have 2 corresponding angles congruent in one triangle and in the other triangle, then they have to be similar. So all you need is 2 matching angles from one triangle to the other. So we'll do a couple examples. We're just determining if the triangles can be proven congruent or similar based off of angle-angle similarity. Okay, so if you notice, I have angle A is congruent to angle D, and I have angle C congruent to angle F, and that is enough to use angle-angle similarity. So are they similar? Yes. Okay. And then it says, if yes, write a similarity statement. So all that means is I'm just naming my triangles. So I'll name my first triangle, triangle ABC, similar to triangle. And if A is congruent to D, they need to be in the same position, and F is congruent to B, therefore leaving E to be congruent. Second example. Okay, they didn't give us the angle measures, but they did tell us that V and Y are congruent. And then we know that vertical angles are also congruent. So again, by angle-angle similarity, yes, these are similar. And we'll name our first triangle WVX, similar to second triangle. Well, W has to be congruent to Z because they're the only ones without the markings left. And then V has to be congruent to Y because they have the one congruent angle marking. And X is obviously congruent to itself because of the vertical angles. Okay, let's go over to our next theorem, side, side, side similarity. And what that says is if all the sides in one triangle are proportional to all the sides in the other triangle, then the triangles are similar. So proportional means we'll set ratios of corresponding sides equal to each other. Okay, so if we look at 3, all right, I'm going to choose the smallest side for my little triangle and compare it to the smallest side of my big triangle. And I'm going to reduce that. And then I'm going to do the medium side of my small triangle over the medium side of my big triangle and reduce that. And I'm going to do my big side of my little triangle, my big side of my big triangle, reduce that. Since all the ratios are the same, that means all the sides are proportional. So we can say yes, these are similar by side, side, side similarity. And our similarity statement will say triangle PQR is similar to triangle STU. Try another example. So our smallest side in this bigger triangle is 30. So we'll do small side over the small side, 24. And we'll reduce that. They're both divisible by 2. So we'll get 15 over 12. And then I'll do the medium side of my big triangle over the medium side of my little triangle. And since that doesn't reduce, and these are not equal like they're supposed to be, these are not. So those fractions have to reduce to identical fractions in order for this to work. The next one is side angle side similarity. And it says if 2 corresponding sides are proportional and the included angle, meaning between the sides, is congruent, then the triangles are similar. So sides proportional, angle congruent. So if you look at these, already is set up where the angle is in between the sides that are given. So we just have to show that the sides are proportional. So we have the congruent angles. That's really important. That checks off the box of the angle in the middle. And then we need to do our ratio. So I will do the smaller side of the big triangle and reduce that. And I will do the larger side of the big over the larger side of the small and reduce that. Since the sides are proportional and the angle in between them is congruent, these are congruent or similar by side, angle, side, and we can do our triangle similarity statement that says that KJL is similar to NMP. Okay, and the order of those letters matter, so you want to make sure like your long side matches with the other. So if you look at M and P, it should be in the same place as J and L. If you look at KJ, it should be in the place as NM, and that it is. All right, last example. Okay, they've got a sneaky little triangle in here, so just notice that this is here, which means in the big triangle, angle A is congruent to angle A in the little triangle because they're exactly the same angle. So it's a little bit sneaky, but that angle is connecting the sides that we are given. So of the little triangle, I'm going to do my shortest side, 12, over my shorter side of the big triangle, 21. And I'll reduce that. They're both divisible by 3. So I will have 4 over 7. And then my big triangles, or my bigger side, I'll do 15, which is the bigger side of my little triangle, and 25. And those reduce by 5. So I'm left with 3/5. And 4/5 or 4/7 and 3/5 are not congruent. So their sides are not proportional. Therefore, these are not similar. So we'll do some more examples. So when you get to some of your homework assignments, they're going to be all mixed in together. And you have to decide, one, if they're similar or not, how you know, and you'll state one of those 3 similarity theorems, and then you'll write the similarity statement. So if we look at number 1 to start off, okay, if I look, I see that I potentially could do side, angle, side, but I need to make sure my sides are proportional. So I'll do my shorter side of my little triangle over my shorter side of my big triangle, and I'll reduce it. And then I will do my bigger side of my little triangle over my bigger side of my big triangle, and I'll reduce it. And since those are equal and the angle in between them is equal, then I can say by side, angle, side, similarity, the triangles are similar. And then I have to also do a similarity statement. So you have to have angle, angle, or side, 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 or side, angle, side as part of your answer because it tells you in the instructions to say why. All right. So I'm going to start with the congruent angles. So we'll do F, E, G is similar to triangle. T is the congruent angle, so T and F are in the same spot. If you notice, T and R are on the shorter side of the big triangle, and F and E are on the shorter side. So I'll do T and R next because they'll have to be equal, and that leaves S. So then always go double check and make sure your sides kind of line up. I have my short sides in the same position since they didn't give you a bunch of congruent angles. All right. Let's look here at example 3. So I know these two are equal. Then 53 and 85 are definitely not equal, but we can find that missing angle, and maybe they're equal and will help us out. So in this triangle, I'm going to do 180 minus 42 and minus 53 and see what I get. So I'm going to be subtracting 95, which leaves me with 85. Okay. And then if I do 180 minus the 42 here, minus 85, I'll also get 53. So even though they didn't look congruent at first, all the angles are congruent. So by angle similarity, these triangles are congruent. So we'll write our triangle similarity statement. And how about we do ABE is similar to triangle. And A is going to be congruent to D because they have the same measure, and B is congruent to C because they have the same measure, and B is going to be congruent to itself, and E is going to be congruent to C. So all those will be your answer. Let's do another one. So parallel lines tell us a lot of information. Okay, we'll able to know that since JN and KM are parallel, that these two angles are congruent because they're corresponding. Okay. Likewise, since LM and KN are parallel, these two angles are congruent because of corresponding. So by angle-angle similarity, these two triangles are congruent. So you'll do your triangle similarity statement, and let's call the little triangle KLM similar to triangle. K and J are congruent, so they need to be in the same position. If you notice, L and K have both the two markings, so they'll be here. So even though the same letter, the top part of angle K is not the same as that other part of angle K, so they will be in different positions. And then that leaves M and M to be in the same spot. I'll just do one more. Okay. I have a 90-degree angle in each corner, so that's helpful. And then I have 61 and 34. Well, last time we didn't have matching angles. We just found the missing angles to then see if they kind of completed each other. So what I'll do is I'll do 180 minus 61 minus the right angle, and I'll be able to subtract that. So 180 minus 90 is 90, and 90 minus 61 is 29. So it's a 29-degree angle, which is not a 34-degree angle. So these are not similar. Okay. So hopefully that helps you out. So even when they're all mixed together, you're going to try and match them with side, 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 angle, angle, or side angle, or angle, side angle.